Have I got it muted? Maybe I have it muted. Okay, yeah, we're recording. So we're going to do a little more practice with naming and writing ionic and covalent and acidic chemical formulas. And I'm going to random select from my many papers here. And we're going to start with this one. So if you have got TeO3 up at the top of your page, raise your hand real quick. Okay, that's Samantha. Anybody else? All right, Samantha, there's not a lot. Well, actually, there's most of them left that at least have one open there. So take a shot. Which would you like us to work? Number 12. Oh, no. Sorry, it's been done. 13? 19. Excellent choice. Okay. So for 19, we've got cobalt-3 carbonate. I'm going to follow my flow chart.
Teachers, please pardon the interruption.
All right. So I'm going to follow my flow chart here. Does it start with H? No, of course not. Does it begin with a metal that has more than one oxidation number, such as cobalt? Why, yes. Yes, it does. Oh, wait a minute. I brain farted. We're not naming. We're writing formulas, which in a way is a little bit easier, I think. So we're going to go with cobalt-3 carbonate. Now, cobalt-3 tells me what the charge of cobalt is going to be, right? It's going to have a charge of +3 because of the 3 there. Carbonate ion, I look up on my handy-dandy ion chart. It's up here in the -2s. It's CO3 with a charge of -2. CO3, charge of -2. Now my two charges are not the same, so I'm going to use my cross it over trick. Okay, I'm going to take my 3 and cross it down here, and I'm going to take my 2 and cross it down here. So that's going to give me C cobalt 2. Since I've got more than one of these, I'm going to put them in a trench coat. So CO3, cross my 3 down, 3. So that's cobalt 3 carbonate. Okay, I went awfully quick there. That's a great place for lots of questions if anybody has one. Gone. Okay. All right. Well, that's 1 down, 4 more to go. If you have the paper that begins with NaOH, raise your hand, please. All right, that would be Avis and Erica. Avis, go ahead and pick us out one that hasn't been done twice.
20.
Number 20. All right. Okay, well, number 20 got done earlier today, so you've still got a chance at this one. It's manganese 7-phosphide. So, again, just like we did a while ago, I look up the charges. This one I don't have to look up the charge for the positive because it gives it to me. Phosphide is just a phosphorus atom by itself. Now, a couple places where I could find that. I could either find it on the ion chart in the -3 column. The other place you can look and find that is on your periodic table that you annotated, and phosphorus has got a -3 up here at the top. So it's a fair bet that phosphorus by itself is going to be -3. So again, using my cross it over trick, I'm going to cross the 3 down to here and the 7 down to here, which means I'm going to end up with Mn3 P7. And it's just that easy. Okay. Erica, you are the other one, so pick one out for us. Say again? 15. All right. Okay, I love it. 15, diphosphorus pentoxide. Now, the first thing that should stand out to you right there is we've got prefixes, right? Or prefaces. Got the prefix di. You've got the prefix pent. Anytime you see prefixes, what that should tell you is that you're doing a covalent compound. Remember, with covalent, you're going to use your Prefix is there to see how many of each thing you're doing. So we've got dinitrogen. Di means 2. Wait, is that the right one? No. Diphosphorus. Di means 2. So it's going to be P2. Pentoxide. That's oxygen. Pent means 5. So O5. And that's that. Are there any questions with either of those?
Why don't you have to do the crossover?
Okay, because the only time you have to do the crossover trick is when you're trying to balance positive and negative charges.
Oh, since they're both positive.
Well, since they're not stealing electrons, they're not positive or negative. They're sharing. Remember, in covalent, you don't have ions. You just have one or more shared pairs. So here, all we have to worry about are the numbers of atoms that they give us in the name. Okay. The big trick on that, and the one that I've seen people having a hard time with independent practice today, is remembering to check to see that you have both nonmetals. Okay. So if you've got another one, like I'm going to go ahead and spoil this one. So number 9, boron and oxygen, those are both nonmetals. So I'm just going to use my prefixes for that. And here's a freebie. So that would be 2 of those. So that would be diboron dioxide. Okay, and for 2 of you, that's like, hey, great. For everybody else, you're like, big whoop, I don't have that one. Questions? That was good. 2 down. If yours has CAF2 at the top, raise your hand. All right, that would be Emily and Shiloh. Emily, pick us out a winner.
18.
Number 18. All right. Okay. Manganese, Roman numeral 4, nitride. So here, because we can see 2 things. 1, manganese is a metal. 2, we've got a Roman numeral. We know this is going to be ionic. So here, I've got to go find my 2 ions. This one, I don't need to look up the charge on because it gives it to me in the name. So manganese is +4. Nitride is -3. And again, you can find that either on the ion chart or on your periodic table. Since these 2 are not the same, I'm going to use my crossing over trick, which means how many manganese am I going to end up with? Mn3, and then N4. Questions? We've been hitting an awful lot of writing formulas and not so much naming names, and that's fine if y'all are good with naming names. Okay, Shiloh, or wait, was that? Yeah, that was Emily. So Shiloh, hit me with another one here. Number 10. Okay, cool. All right. So this right here, there are actually a couple possible right answers for this, and I'd like to hit them both. So following my flow chart, the first question on the flow chart asks, does the formula begin with H? And why, yes, it does. So that tells me that this is an acid. Does this acid contain a polyatomic ion? Why, yes. Yes, it does. It contains that Cn ion. So does the polyatomic ion end in ate or ite? Actually, it doesn't end with either, does it? It ends with ide. So that kind of breaks this. This is going to be one of those situations where we're going to have to fudge the rules just a little bit to make it fit. But let's put a pin in that for a minute. Let's go back and try and just name it as an ionic compound. Okay. If we did that, then the first one's going to be hydrogen. We don't have to say hydrogen 1 because hydrogen can only ever be 1. But we do need to find what the Cn ion is called. And it's over on the right-hand side in column 1. It's called cyanide, correct? So we might just call this whole thing hydrogen cyanide. I'm thinking, and we might have to Google this. Possible other answers might be something like hydrocyanic acid. And I know I'm using the hydro here when that's really only supposed to be for binary acids, but you'll notice there's no oxygen. So it's not technically an oxyacid. We might call it like cyanidic acid. We'll put question marks on those. I know for a fact that that one is legit. But remind me in a few minutes, and we'll go do a Google search, and we'll see what we can find on that one. Yeah, I'm glad you brought that one to my attention. Questions? 3 down, 2 to go. Okay. If you have CaOH2, I almost told you the name. That's funny. At the top, raise your hand. So that's going to be all right. McKenna, go ahead and pick one out for us. Number 20. Okay. All right. I'm seeing a tri down there, which tells me it's going to be covalent. So all I have to worry about is symbols and numbers. There's no prefix here, so I know I've just got one of these galliums. Gallium is Ga. Trichloride means I'm going to have 3 chlorines, so Cl3, and I'm done. Okay. Haley Jones, pick us another one. Number 9. Okay. Excellent. Okay. CuSO4. All right. So going to my flow chart, it does not begin with hydrogen. It does begin with a metal that has more than one oxidation, and I know this because it's one of the ones that it lists as a possible example. Okay, which you can't see through my big fat leaf-covered head there. Okay, and that's copper. So then I follow the yes arrow, name the first element followed by its Roman numeral, and then name the second element or polyatomic ion. There we are. So the first one is most definitely copper. Let's scooch this over just a smidge here. I'm going to leave space for a Roman numeral because I'm going to need one. SO4, when I go find SO4, it's on the negative side, and its name is sulfate. And upon further investigation, I find that the sulfate ion has a charge of -2. It is totally copper 2 sulfate, because this has to have +2 to make that work. All right, very good. Any questions on either of those? Okay, so that brings us to our last page. So everybody else, whoever's got BR2 up at the top, okay, who all is that going to be? Reed by himself? Okay, Reed by himself. Pick me out a thing. No pressure. 14. Hydrophosphoric acid. I like it. Okay. So, hydrophosphoric acid. Now, I'm going to have to see if I've got a copy of this that hasn't been totally marked up here, and I do. Remember, for naming acids, it's either going to be a binary acid or it's going to be an oxyacid. So if it's hydrophosphoric, which one is it going to be? Okay, how can you tell? Starts with hydro. So that means it's just going to be hydrogen plus one other element. So what's the other element going to be here? Plus phosphorus. Okay, now, phosphorus, we need to find a charge on. Hydrogen's +1. Phosphorus, you could either check on the periodic table, or you could find phosphorus by itself on the ion chart. And when you do, you find that the phosphide ion is -3. So when I do my crossing over trick, I'm going to end up with 3 hydrogens and only 1 phosphorus. So it's H3P. Are there any questions about that? I think we had a pretty decent sampling of different problem types in there, so I'm going to go ahead and, wow, 15 minutes, that was quick. I'm going to go ahead and stop the recording.